Hello, and welcome back to Prompt Circle, where we live and breathe AI automation solutions. If you're looking to launch an AI automation agency or you're looking to harness the power of AI to streamline your business, this is the place for you. Here we offer tutorials that show you how to build AI-driven applications very quickly and very fast so you can launch that for your clients or for your business. So if you like what you see, go ahead and hit the subscribe button and also turn on your notifications so you never miss our weekly content. All right, so today we're going to be looking at an exciting project. We're going to be looking at how to build an AI-driven course helper bot. Now, this is going to be really helpful and game-changing from anyone who is managing online courses or coaching programs. It is basically like having a digital version of you, right? So, your students might have questions or need help to solve certain problems when they get stuck. And this bot will be able to provide them with the guidance that they need, the responses that they need in real time. Now, I'll take you through a tour of my own course program where I am using this bot to save a lot of time. It's been really amazing because my students have been really excited about using it. I have this course where I have gone through the step-by-step guide of building large language model driven applications from start to deployment. If you're thinking about building like a production grade AI application, I would encourage you to check out the course because it goes through quite an extensive look at all these ways of building these applications. Now, I've paired it with this course helper bot to enable folks to get answers as they use the course, and this has been really eye-opening. So let's take a look at how it works. Now, you can see a few examples here. This one is one that is really cool. Like, I just pasted this message saying that I got stuck with my code, and I provided a code snippet, and it was able to help me troubleshoot and debug my code and tell me exactly what was wrong with my code. And this is based on the resources in the course. So let's ask another question. So let's say I would like to see example code snippets of LangChain agents. So let's see. So we just ask the question and to be able to go pick up that answer and return a response. So let's see what it responds with here. All right, so there we go. So it went in, looked at the course materials and checked out the aspect of it that was talking about creating LangChain agents, and it goes through a step-by-step guide on how to do that. Isn't that amazing? And you can use it to provide really stellar support. And I think that moving forward, students will come to expect these types of services within any particular program. And for me, it's been game-changing. So I'm going to show you how to build this application from scratch. Let's dive in. All right, so to create this application, we're going to be doing a few things. One, we're going to be creating a Slack application that would allow us to obtain our bot token and our app token, which we're going to be using in the app. We're going to need an API key from DeepLake. DeepLake is the vector store we're going to be using. It allows us to store all of our course materials in a vector store as embeddings, which would allow us to retrieve the responses back from it much easily. We're going to create a vector store function to do the upload, and we're also going to create a retrieval logic which would allow us to retrieve or extract valuable information from the embedding back to the user who is submitting the query. Once we're done, we'll combine it all within a Slack application, and our course helper bot is ready to go. So let's start by creating a Slack application. All right, so let's go ahead and create our Slack app. Now we're going to do this with a method that I've not used on this channel. So we're going to use the app manifest method. Now I have created a manifest file, which I have dropped inside the repository, which you can just basically copy and paste when we get to that spot. So now we're going to select our workspace. And next up, we're just going to basically paste our manifest file in here. So it can either be in YAML or in JSON. And what this does is basically declaratively defines what your app is going to be all about. So here it talks about basically the course, the app name, the description. It also kind of talks about, you know, what we want our bot to be called, what scopes we're giving our app, as well as what events we're subscribing to. And finally, we have our socket mode enabled right here because we're setting it to true. So once you're done with that, all you need to do is hit next and go ahead and create your application. And it's really the easiest and fastest way to create an app if you know how to declaratively define your app in the manifest. Now we can go ahead and install it in our workspace, and there we go. We didn't have to really go clicking around for a lot of the things that we needed. So now what we need to do is go into our OAuth permissions, copy this bot user token as usual, keep it somewhere safe because you'll be using it in your application. Next up, we want to go ahead and get our app token. So this will be our app level token. So you want to go ahead and generate a token here. I'm just going to call this app token. And in your app token, you need the connections write permission, and all you need to do is hit generate. Again, copy the X app token right here, and we're going to be using it in our application as well. Remember to check this piece that says allow users to send /commands and messages from the message tab. This allows you to communicate directly with your bot. All right, so that's it for Slack. We're all good to go. Everything is ready to rock and roll. Next up, let's just make sure, yeah, events description is ready. Yeah, everything is ready to go. The next thing we want to do is go ahead and obtain our API key from DeepLake. So go to app.activeloop.ai. I'll put a link in the description. I think this vector store is one of the better vector stores, I would say, from my perspective, just simply because they provide a ton of really cool free services, really great support, really great tutorials, well-written documentation, and they also provide support for you to visualize your data set, as well as supporting multimodality. So they support both text and image type of embeddings, which is pretty awesome. And they have a generous 200 GB managed tier for you. So really modern enough for whatever projects that you might want to do. So right here, you want to create your API token, grab your token. Once again, keep it safe. And finally, also, if you have signed up for OpenAI or any other large language model where we're going to be using OpenAI in this case, you need to grab that token and keep it safe because you're going to be needing it as well. Next up, let's go ahead and set up our environment. In your terminal, go ahead and use your mkdir to create your course helper bot directory. You want to cd into that course helper directory, and then you want to set up a virtual environment to make sure that your development environment is well organized. And then next up, you want to export the following tokens. Remember, we're going to be using you can also create this in an environment variable, by the way. I will do that inside the repository so you can see a template of what you need to use. So in this case, you're going to be needing your Slack app token, your bot token, which we created earlier on, your OpenAI API key, and then your active loop token. So all of those would be what you would need to create your application. Now, next up, let's go ahead and install some of the important libraries we're going to be using in this app. All right, so let's go ahead and install the relevant packages that we need for our application. So first we need our Slack Bolt package. So this basically abstracts a lot of the heavy lifting for building Slack applications and really simplifies it with this SDK. Then we're going to use our OpenAI library, which gives us access to our large language model. We're going to use DeepLake for our vector store, Tick token for our embeddings. We're going to use LangChain because that's the library for large language models. If you've not used LangChain in the past, I've talked about it quite extensively, both in my videos as well as my course, check the description below to get more information about that. And then finally, we're going to have to also install PyPDF, because we're going to be doing some PDF processing, and then our python.m, which is purely for accessing our environment variables. Now let's jump into creating our vector store function. All right, so before we actually go ahead and create our vector store function, we want to actually access the document that we're going to be converting into embeddings. Now, we're basically using this information to train our bot to have access to the right information, so that whenever a question is asked, it does have all the information it needs. Now, I use Notion in creating my course, so all the course outline, the data, the code snippets, every single thing is right here in Notion. So all I really need to do is export this, and you can just do that by going in and exporting this out of Notion. And in my own case, I'm going to be exporting it as PDF. And once I run that export, I can bring that export into my application and convert that into embeddings. So, all right, so I'm going to be using my Visual Studio Code for this. So if you've set up your application the way we have already done it when we're doing our setup, you should have something like this. Now I've gone ahead and created a function called vector store function .py. Actually, I need to change this name. It should be vector store dash function .py. So this is basically the function that is going to be managing our vector store embedding. All right, so let's talk about our vector store function. Now, our vector store function essentially does one simple thing. It takes our PDF file, which we just recently exported from Notion, and it converts it into embeddings and then stores that information as embeddings inside Deep Lake. And now once it's stored in Deep Lake, you get a dataset path which you can then use for your retrieval logic, which we will see very shortly. All right, so let's go ahead and step through the code. So again, we need our OS, we need .env, we want to import load .env, which we're going to use to access our environment variables, which is right in there. We want to bring the OpenAI embeddings. So this is an embeddings model that is used basically to convert text into embeddings. Embeddings are numerical floats which represent your data. It makes it much easier to retrieve contextual search results given a specific query. And then we're going to be loading up our PyPDF loader, because we want to be loading in our document and using it, converting it into the right format, which would be ready for embeddings as well. And then we're also importing Deep Lake. So the very first thing we want to do here is we want to obtain our document. So our document is called course_materials.pdf. I'm going to copy the relative path and paste it right here. So that's course_materials.pdf. So this is the data that we're going to be embedding. Now, what we want to do first and foremost is that we want to pass it through PyPDF loader. So we're passing this document inside our PyPDF. And what is the PyPDF loader does basically is to convert the data into LangChain documents, right? LangChain documents are basically text documents which you can then use to convert to your open embeddings. But before you actually convert them into OpenAI embeddings, it's always a good idea to split them. So that's why we're using this function called load and split. And what it does is just splits it into different pages. So depending on the number of pages that I have, it's going to split it across those pages. Now finally, we want to set our embeddings function, because we're going to be using it very shortly. And then we want to proceed to declaring or defining our Deep Lake vector store. So we're storing it in this variable called db, and we're using from documents because this is a document. So what we've stored here is a document after we've loaded our PDF. So from documents, we're passing in the documents, which we're calling pages, right? We can call them documents as well to make it easier to understand. So let's call it documents, and we're passing documents right here. And next up, we want to set up a path. So our path is just basically where we want to store our data. So we can call this course bot doc for now. So basically, if you have set up your Deep Lake, you can basically use your Deep Lake username and create a path. Your dataset path is basically where all your information is going to live. And then finally, you're passing in your embeddings function, which is going to do the embedding. So this is all you really need to make this work. So I'm just going to go ahead and save this, and we're going to run this. So we're going to run Python vector store function.py. All right, so once we run this, and basically what you're going to see is that it's going to start processing the document. So it's going through the process, it's creating our data set right now. So it's created the data set. Now it's going through the process of basically converting them into embeddings, and it's going to store those embeddings inside Deep Lake. And I'm going to show you what that looks like inside Deep Lake once it's completed. All right, so we see now that our Deep Lake vector store has been created. So you can see the number of embeddings. In this case, we have 19 of them. So basically 19 pieces of data has been chunked up. So now it also provides us with the path. So we can just go directly to this path and see what our data set actually looks like. All right, so this is what our data set looks like now that it's been uploaded. As you can see here, you can also visualize it. We have about 18 pages, or 19 pages actually, because it starts its index from 0. So basically there are 19 pages. Now, if you want to see what's going on in each chunk, when you click on it, you will see that it contains text data. It also contains some metadata about the text we've uploaded, so the source and what page we're talking about. And then finally, you can see those embeddings that I've been talking about. So this is the list of embeddings. This is what really makes the magic happen, because when a query comes in, that query is converted to embeddings and matched against this list of embeddings. So this makes it very efficient to retrieve information versus using the text-based search capabilities that we've always used in the past. So now let's go ahead and do a retrieval to see how to get back our data. All right, so now that we have our path returned, we want to grab that path because we're going to need it very shortly. So I'm just going to take it right here. And now we're going to jump into creating our Slack application. Now I've gone ahead and written it in advance, but I'm going to step through exactly what's going on here. So what libraries do we need? We need our OS library basically to access our environment variables. We need our Slack Bolt application to access our app class, which basically abstracts quite a lot of things when it comes to building Slack applications. We've gone through this in previous tutorials as well. We're also bringing in our socket mode. Our app is going to be running in socket mode. This makes it easy for local development. So we're going to bring in our socket mode handler. We're also going to bring in our .env, our load.env module. And then on the LangChain side, we want to initialize our OpenAI large language model. We're using the GPT 3.5 Turbo, which is why we're using Chat OpenAI. If you're using any chat models, you're going to be using LangChain.chat model. So this is for Chat OpenAI. And then for embeddings, we're using the LangChain.embeddings .openai to retrieve the OpenAI embeddings function. And then we're going to be using the retrieval QA chain. The retrieval QA chain basically is for question and answering against a vector store index. So it is specifically designed to do that, to ask questions specific of a vector store and return responses accordingly. We also do have Deep Lake, which basically is our vector store. So basically LangChain has provided a wrapper that allows us to access APIs from Deep Lake. So the very first thing we want to do here is initialize our Slack application. So let me just go ahead and add a few comments here. So initialize the Slack application for it to run. And what we want to pass here is our Slack bot token. Next up, we're going to set up our retrieval QA chain. Now, to set up our retrieval QA chain, the first thing we want to do is to declare the embeddings, because we're going to need embeddings. Remember, when you set a query, what first happens is that the chain converts that query into an embedding. The embedding is used to match with the embedding that we stored in our data set. Then it returns a set of documents that is passed as context, which the large language model then uses to provide a response. That is the typical thing that is going on here. So here we want to set our data set path. We already have a data set path from the earlier function, so we want to keep it right here. Typically it's hub colon / your username or your org name / whatever your data set name is. You can also obtain this directly from Deep Lake as well. Now we want to set our embedding function to embeddings, which we have already declared up here, and we're setting it to read only because we only want to extract information. We're not looking to do any update operations or add operations. All right, so we're going to be using our GPT 3.5 Turbo 16K0613. So that's the model we're using right here. And then we're now going to set up our chain. So our chain is going to combine a lot of the things that we already had. So it's saying from LLM, and you can also use different types. It could be, from chain type or different methods. But here we're using from our large language model, which we have defined, and then we are passing in the retriever. So we're saying our large language model is going to use this retriever to retrieve information, and then the large language model is going to take that information and provide a response back. So here is our chain. Our chain is ready to go. So as usual with any Slack application, you can listen for an event using this annotation app.message. Here we're listening for any type of message that is coming in, and we want to be handling that as it comes in. So what we're going to be doing here is we're going to set response. So we're going to say response is equal to QA.run. So it's going to be QA.run, and we're passing in the message text, which we had defined earlier on. So it's a response equal to QA.run. All right, so we provide an index right here, and then we should be good to go. So we set our message text to message, and we extract the text from that message. We set up our response, and then we say a response. So our application should be ready to go now. So all we need to do is go ahead and save this, and then we want to run our app. So we go Python 3 app.py. Should show us that our boat app is running, so that would tell us that our app is ready to go, and then we can go ahead and try it out. So it says that our Deep Lake dataset already exists, which is good. It's loading from storage, and our Bolt app is currently running. So let's go ahead and test our app and see how it works. So I'm going to say, hello, I would love to learn about the API chain. Use code snippets to explain. So let's see how it's going to function here. Okay, so as you can see, it's entering the retrieval QA chain, which shows that our app is actually working, and now it's actually finished the chain, and you can see our response right underneath. So it's gone ahead, it's provided us with a response that is coming directly from the document that we provided, and it's also providing some guidance here as well. This is pretty awesome. I mean, think about it. You could use this to really add a lot of value to your students, to people who are, involved in your community without having to be there to guide them through every single aspect. Now, there are different ways that you can modify this. You can basically improve the prompt, make it sort of different in the way it responds. For instance, in my own course, I'm going to be sampling how to infuse things like emojis and things like that. That makes it even cooler. And also you can do things like threading your response. And remember, you don't have to use this only from a chatting perspective. You can use this in your shortcuts, in your commands, in different ways to make your application pop. But this is not only restricted to Slack. Easy to do it in Slack because you have the platform there, but it can also be an external facing application. It can also be in Discord, in Microsoft Teams, and those type of applications. Now, if you want to learn how to build applications like this, be sure to check out my course. It's a comprehensive course that goes through the step-by-step of how to build large language model driven applications from start to finish. Including how to deploy to production. It gives you also access to my internal Slack workspace channel, where you would have access to play around with the bots that we've built in the course, as well as the course helper bot as well, if you want to play around with it. Thank you for making it this far. If you find this type of content exciting, if you're building out your AI automation agency and you're looking for technical know-how to actually turbocharge what you're doing for your clients, or you're doing it for your own business, or you need help doing it for your own business, feel free to leave a comment in the comment section or reach out. And I would love to hear more about your journey, how it's progressing, and love to see if there are ways that we can collaborate to help you out if you need that. Until next time, have a great one.